Hey guys, welcome to Bar Z. My name's Stan, and today we're going to go over to the bench and make some drawings on how to install this type of drive, this type of VFD on a lathe. It's for an online buddy that's going to be fitting his lathe with a three-phase motor. He's only got single-phase power, so we're going to use it to generate the third phase and give it a speed reference and control it, all with the low voltage control power that's coming out of the VFD. So let's go over to the bench and get this thing going. Hey guys, welcome to Bar Z. My name's Stan, and today we're going to do a little bit of electrical schematic primer, and I'm just going to go through my book and put away some cut sheets that we don't need anymore. These are all kind of a shop, it's kind of a shop book with shop sketches and stuff. And we're going to find us a clean piece of paper. I've been busy lately, so the cut sheets are pretty plentiful. Alright, here's a clean one. Let's tell you what we're going to do today. We're going to use a lens drive. This is an SM vector control. This is a sensorless vector, 2 horsepower, and we're going to be outfitting a lathe with it. So it's got some special requirements for control, and it's got some things that need to happen for power. So we're going to draw the power on one page like I usually do, and then we're going to draw it again for control. So let me get it. Let me get to the right page here, and we're going to. I'll get some rough sketches on here. Then we'll come back and connect the dots. Hopefully, it all makes sense that way. Power wiring is all on page 16. Your incoming power and your outgoing power. So the power wiring is very simple, in and out. But we're bringing single phase in, taking 3 phase out. We're using this VFD to generate the third phase, and we're also going to use it for a little bit of speed control with a 10K pot. But let's get the power wiring done. Let me get some stuff drawn up. I'll bring you back. Okay, we're here with the power wiring. This large box is the actual VFD, and down at the bottom you've got L1, L2, and L3 incoming power. PE is your ground, and then U, V, and W are your outgoing, which are going out to your motor. These two represent your SO cord that we're going to be using. We're going to be using an SO cord to feed it, and then we're going to be using an SO cord out of the VFD out to the motor itself. Now I've got a 2 horsepower 6.8 full load amp shown here with its 3 terminals. Now the SO cord has got a red, black, white, and green. This is going out to a 20 amp circuit off to the wall. Essentially it's just going to be a plug, so you can unplug the machine and power down the VFD safely. The plug is a perfectly acceptable disconnection means, but we need to power up the VFD. This one is single phase and 3 phase incoming. We're going to be using this one here. We're only going to be powering up L1 and L2. L3 is left open. So we're going to take red to L1. We're going to take black to L2. We're going to take green to our earth ground. And white gets clipped, unused. So we're not bringing anything in with the white, and over on the plug side, don't do anything with that. It doesn't matter if there's a spare wire in there. So we only have 2 current carrying conductors inside that cable. On your outgoing, we're going to be using red, black, and white as current carrying conductors, and the green again. We're going to bring the green back to here, tie it into PE, and that also goes to a chassis ground. And then green also goes down to your motor. Let's get these done. We got a chassis ground there on the motor. Red goes to U. Black goes to V. White goes to W. And then those 3 we're going to go to your motors on your T1, T2, and T3 input. Follow the wiring diagram on the motor for low voltage. So red, black, white. And this is power wiring. So pretty simple, 2 in, 3 out. These just represent an SO cord. You know, the conductors don't really care what color the jacket is on them. So if you flip-flop red and black, it's not the end of the world. You know, the electrons have no idea what color that jacket is, so they'll pass the current one way or the other. It should be noted that if you need to reverse rotation on your 3-phase motor, flipping the incoming to a VFD does absolutely nothing. The motor will still run the incorrect direction if you start it up and it's running backwards. Only by switching the wires at the outgoing here or right at the junction box on the motor. That's the only way you can reverse rotation on a 3-phase motor. The line conditioners and everything within the VFD won't allow you to flip these and have a end result out the other end of reversing rotation. So it should be noted that's the only way to reverse rotation. Okay, let's move on to a control. Put a blotter in back here. And let me get that drawn up, and this one's a little more complicated, but what we're gonna do on this drawing, we're gonna get the pin rail, which is a very small connector rail within the VFD, which is actually the control end of it. And then we're gonna be drawing the controls, which are, we're gonna be using an on-off control switch for reverse, off, and forward run. We've got an E-stop in there, and we've got a 10K speed pot. So let me draw this up with all the components, and then we'll come back and connect the dots. Okay, welcome back, and we've got our control set up here. And we've got 3 elements that we want to control. This control and this rail represents the control rail inside the VFD. But we've got 3 external elements. We've got a reverse, off, forward switch, which is a 3-position rotary switch, maintained contact. We've got an emergency stop, which is a maintained contact. And we've got a 10K pot, which is a speed pot, and it's got the 3 connections on it, which the center one is usually the wiper. So you're gonna, basically this is just a variable resistor. So the center one's gonna be your wiper, and then one's gonna be the high and one's gonna be the low. But this is how we're gonna wire this up. Let's start with the 10K pot. Our speed reference is on, I gotta find it in the book now. I just had it, here it is. Our wiper is on 5. So we're gonna bring 5 down to this guy here. We're gonna bring 6 to the high, and we're gonna bring 2 to the low. So pretty simple. The VFD generates its own control voltage within itself, so it's sending out the power on 5, and depending on what it gets back on 6 and 2 is what you're gonna get for a speed reference. Okay, sorry guys, I had to get the phone real quick. Okay, recap. We already did the 10K pot. Hoping the camera caught all that. Next up, we're going to do the forward and run, the forward and reverse run commands and the off. Pin 4s are common. We need to link 1 and 4 together. We're going to bring these 2 together, and then we're going to go down, and we're going to go through the E-stop so that the forward and reverse get no chance of getting any of the common control voltage when it's in E-stop. So we're going to go through this E-stop here. We're going to come out of the E-stop, and then we're going to power up both reverse and forward run contacts expressed here and here. And then we're going to take those back to 13A and 13B. 13A is going to be our forward run. So we're going to come here to 13A. I'm going to have my wires crossed here. And then reverse is going to go to 13B. And that's going to give us our forward and run command, forward and reverse run commands, and it'll also give us off. You know, we can turn off here, but if you hit an E-stop, this completely disables this switch. So it should be noted that this does not power down the drive. All this does is take away the control. so that the machine cannot be started if this lever gets flipped. If it's down somewhere next to your leg on the machine and it gets flipped by accident, you know, and you're trying to set up a part, you don't get your hands tangled in the machine. An e-stop is a good visual indicator, and it's a nice big button if something's going on and you're tangled up. You got a big fat mushroom button to hit. So those are our 3 controls. Next up, we're going to go through the commissioning part of it and show the programming for this, and how to program the drive so it accepts all these commands, because right out of the box, they write off the keypad right on the cover. So we're going to go through the parameter groups next and show the parameter groups for setting these controls. Okay, well, I got some good info out of the book, and I think these are everything that are going to apply to this this drive. I'm going to go through them. These are all the parameter numbers that you're going to get when you start scrolling through the keypad. This is what it's going to do, and these are the values that need to be put in. So I'm going to run through them, and these are all in order in your book that you're going to get with your drive. And it starts at P100, and the P100 is your start source, and whether the default is 0, and that's from the local keypad, that's from the actual face of the drive unit, but we want to use the terminal strip. So we're using the terminal strip to command the drive, so we're going to set that value to 1. Now we're going to go to P101 is the speed reference. How are we going to throttle the VFD up and down? Now default is 0, again off the keypad, but we're going to use a 0 to 10 volt DC potentiometer, and that value is 1 for a 0 to 10 volt DC. There's other things you can do. You can do a 4 to 20 milliamp. You can do preset speeds, or you can do speeds based off of a network. Control it from a PC. We're going to slip down to 104. 107. This is our line voltage selection. And we're going to choose 1 here. On 0, it's 200 volts, and on 1, it's 240 volts. So we've chosen 240 volt to match his voltage. Next is motor overload. Now this is kind of important. We're basically programming the drive to shut down in the event of a motor overload. This replaces your little overload block and your little thermal overloads. That's parameter 108, and you set that for a percentage of the drive, and it's variable anywhere between 30% and 100%. Factory is set for 100% of the drive. So you have to take your amps of that the drive is rated for, and do the math against the amps of what the motor is rated for, the FLA, full load amps, not service factor amps. So you take the full load amps and turn that into a percentage and put that value in P108 for your motor overloads. That'll give you running protection for your motor. Next up is P111. P111, here it is. That's a stop method. We're going to coast to stop, so that value is set to 0. Next up is we're in P112. We're going to enable the reverse rotation. If you don't enable P112, you don't. It'll only be capable of running in the forward direction. So we have to enable reverse. P112 value is 1. Next up is P121. Let me get there. These are, we're programming, at this point we're programming these terminals here, 13A and 13B. Remember that was for our forward and reverse run commands. So where were we? Okay, 121, parameter 121, that's your 13A function, and we're going to program that for a forward run command. That is a value number 13. Next up we're going to go to P122, that's for our 13B function. And that's going to give us a reverse run command, and we're going to put that value at 14. Next up, we're going to talk about skipping frequencies. Let's say you get the machine started up, and it runs good at 55 hertz, and it runs good at 57 hertz, but at 56 hertz, the machine shakes, and it puts out all kinds of noise, and you just don't want that to ever be a factor again. They've got a feature called skip frequency. And that's parameter 181 and 182, so you can skip 2 very specific frequencies. So, and you just put those in. I wrote in here as needed. After you get the machine started up and everything's running, and you've got one spot that you really hate the way it runs, it makes noise, it vibrates, it chatters, or doesn't cut good, or who knows, you can skip those frequencies. So no matter where you set your speed pot, it will either go above it and below it, and will always ignore the frequencies that you put in here. The other one is, and that's 181 and 182. The next one is P184, and that is skip frequency range. So if you had a band, let's say between 52 hertz and 55 hertz, we had a problem in there and the machine didn't run good in that range. We can skip that entire range and plug those numbers in as needed. So those are your skip frequencies, the 181, the 182, and the 184. So those are handy to have. Default values are set to 0, so these basically get ignored when the drive's right out of the box. But it's good to know that you can always skip a frequency. I'm not going to touch on it too hard because these are pretty advanced uses, and you have to be physically sitting at the machine to run these. And this starts at parameter group 300. These are vector parameters. This is your torque boost. And you have to know everything about the motor, and you have to actually run it and witness what is going on with it to get torque boost and things like that. You've got an auto detect function where it's going to detect the poles of the motor, the line voltage, the current draw, and things like that. So between parameter 300 on, use caution in doing it, but with a little, if you apply what make a change, one change at a time, apply what you've learned and make adjustments accordingly, the vector parameters just make this drive come alive on the torque boost. At the low end, if you're tapping something and you need a 20-second boost to get through a tapped project and you're running at a really low speed, it will actually make rated horsepower all the way down to 20% for short bursts, 10, 20 seconds. These parameters will make your drive run hot. But there's a lot of times where you need a torque boost. Let's say you had a conveyor line that was just loaded up with all kinds of parts and it's dead stopped, and we need a bunch of torque to get all those parts in motion. And after they're in motion, we don't need the torque boost anymore. But just getting them up to speed is a problem. So the vector parameters are good for that. They're good for heavy tapping and heavy cutting and things like that where you need short bursts of power. But you can't rely on that to be a constant. And I just want to make that clear about the vector control. All right, so we've got parameters, we've got control, and we've got power wiring. We're going to take all three of these, we're going to rip them out of the book, and we're going to send them on down the line to the guy that needs these more than I do. He needs these to wire up his lathe. So I hope this is easy enough for you to follow, and we'll catch you on the next one. Okay, so let's get this box ready. We're going to start off with some power cable, which is our SO cord. There's your 4 conductor. So that's good for the power into the VFD and out of the VFD. So we got, I don't know, about 20 feet there. We've got a cord in there, plug, wall receptacle to match, both 20 amp rated. We've got we got a box and a cover. Put that receptacle in and mount on the wall. That's as far as my liability takes me. We've got tie wrap bases and tie wraps. We're going to bag those and get those ready to go. And then we've got cord bushings. This is a large cord bushing here. This is going to be from the wall to the drive and from the drive to the motor. So we got 3 of those large ones there. Then we got 2 small ones, and those are going to go from the drive up to the control box. So those are for the belting cable. So we've got 2 for the control and 3 for the power wiring. What else have we got? Oh, we got some control cable here. We've got a 3 conductor Belden cable here. That's a shielded cable with 3 conductors. That's for the speed pot. So he's, I don't know, about 10 feet there. And then we've got another one here for the forward and reverse run commands. That's a 4 conductor there, and he can use whatever he wants out of those. So we've got our 2 control cables there. And then we've got our instructions. We've got our power wiring, our control wiring, and our parameter group. So that's the kit right there. That's everything he needs to get this thing going. Everything else he's picking up locally from an online resource. All right, so that's the end of this. Wish you the best of luck. Hope your lathe runs real good. Okay, so there you have it. I hope all that was clear to you guys. You know, I kind of powered through it. Those parameter groups are pretty second nature to me, so I just kind of blazed through them without really going into a lot of detail. So I know what all the parameter groups do in my head, but I was trying to get through them so we don't have a lot of video time, but also that you guys can make an informed decision when you go to buy your drive or program your drive. These drives, the SM Vector Control has a very intuitive book. They're made here in the US, the literature is printed in the US, and you get an actual book with every drive. You don't get a CD that you have to sit there and try to scroll through and go back and forth between your computer and where you're working. It's just got a nice little book that you can take with you over to the motor and flip through it and program all your stuff. All right, guys, hope you learned something. Hope it was informative, and hope I didn't melt anyone's brain. Thanks for watching.